Good morning, sir.
Good morning, students. Today we are going to discuss a new topic that is stacks and queues. A stack is a linear data structure in which elements can be inserted and deleted only from one side of the list, called the top. A stack follows the LIFO, last in first out, principle, that is the element inserted at the last is the first element to come out. There are two operations performed in stack, which is pop operation and push operation. The insertion of an element into the stack is called push operation, and the deletion of an element from the stack is called pop operation. There are more operations there, but it is not included in our syllabus. In stack, we always keep track of the last element present in the list with a pointer called top. The diagrammatic representation of a stack is given here. You can visualize the stack as a vertical collection. Also, these are some applications of stack. Some CPUs have their entire assembly language based on the concept of performing operations on registers that are stored in a stack. Also, stack structure is used in the C++ runtime system. Redo-undo features at many places like editors. Photoshop is another application of stack. Also, forward and backward features in web browsers. That's all about stack. Does anyone have any doubt regarding stacks?
No, sir.
Okay, then we are moving to queues. Queue is a linear data structure in which elements can be inserted only from one side of the list called rear, and the elements can be deleted only from the other side called the front. The queue data structure follows the FIFO, first in first out, principle, that is the element inserted at first in the list, is the first element to be removed from the list. The insertion of an element in a queue is called an in-queue operation, and the deletion of an element is called a dequeue operation. In queue, we always maintain two pointers, one pointing to the element which was inserted at the first and still present in the list with the front pointer, and the second pointer pointing to the element inserted at the last with the rear pointer. Here is the diagrammatic representation of the queue. You can visualize the queue as a horizontal collection. Queue data structure is implemented in the hardware microinstructions inside a CPU. Queue structure is used in most operating systems. These are some applications of the queue. Hope you understand.
Sir, I have a doubt regarding queue.
What is it, Samir?
Sir, how many stacks are needed to implement a queue?
A queue can be implemented using two stacks.
Sir, can you please explain last in first out operation once more?
Sure. The last in first out operation, also called as LIFO, states that the element that is inserted last will come out first. You can take a pile of plates kept on top of each other as real-life example. The plate which we put last is on the top, and since we remove the plate that is at the top, we can say that the plate that was put last comes out first.
Sir, why are stacks useful?
They're very useful because they afford you constant time 0, 1 operations when inserting or removing from the front of a data structure. One common use of a stack is in compilers, where a stack can be used to make sure that the brackets and parentheses in a code file are all balanced, that is, have an opening and closing counterpart. Stacks are also very useful in evaluating mathematical expressions. That's all for today.